And ladies and gentlemen, we are back. We haven't left, but I'm back because right now we're going to spend some time performing the classroom activity. So I'd like you to open your books to the classroom activity found on page 43. Page 43, the classroom activity having to do with forces and friction. And before we actually begin the activity, a quick reminder about what is friction. Here's a diagram showing an object in motion in this direction, motion in this direction. You can see friction in the other. Got to get my fingers straight here. In the other direction, let's just go to the next slide, shall we? Oops, not that slide, this slide about friction that you wrote down yesterday regarding friction being a force acting in the opposite direction of a moving object. With that in mind, I want you to consider the problem of the classroom activity on page 43. And it reads, how does friction affect moving objects? I'd like you to take a moment, think about what friction is, and think about what you think might be the answer to that question by writing a hypothesis. So pause me now, if you would. Okay, I'm back, and we are going to do this classroom activity together. And I just so happen to have some materials here that we're going to be using. Now, if you refer to page 43 in your book, hopefully you have written your hypothesis already. And now here are some procedures. And we're going to modify things a little bit with the procedures, but let me show it to you. Then we'll go through it. I'll make some observations on your behalf, and then you can finish up your classroom activity and come up with a conclusion. So here we have a brick. And it's actually half of a brick because, bricks are heavy, man. So, goodness gracious. So I've got a brick and I've placed it onto a flat piece of wood. Now I have another device here. This is actually called a spring scale. And a spring scale does not measure mass, but rather the spring scale actually measures weight or the force of something. So if I were to show you a close-up of the spring scale here, you'll see the capital letter N at the top because the N stands for newtons. Remember, newtons are a measure of force, and this measure of force is how much gravity is pulling down on an object. It's a measure of force. Right now, we're going to be using this spring scale to measure forces in newtons of how much force is required to pull this brick across this flat piece of wood. So I know the numbers are difficult for you to see. So first of all, let me show you how the spring scale works. There's a handle on one side and there's a hook on the other side. We're going to attach this hook to a loop in the string that I've tied around the brick. And I'm simply going to pull gently and steadily the spring scale. And as the brick is in motion, I can read how much force is required to pull that brick across the piece of wood. And it is, while the brick is in motion, it was taking 6 newtons of force. So take a moment and jot that down. Took 6 newtons, 6 capital N, 6 newtons of force in order to pull this brick from one side to another. Now, is there something we could do to decrease that force? And before we get to that, I want you to think about, why did it take 6 newtons of force to pull this string? I was moving the brick in one direction. Was there anything acting in the opposite direction that was causing me to pull with that much force? Pause me and discuss. All right, hopefully you said friction. As I was pulling in this direction, the friction between the brick and the wood were actually pushing in the opposite direction. So here's my next question for you. Is there something we can do to this brick and or to the wood to decrease the force required to pull this brick? What could we do? Pause me and discuss. All right, I'm back, and if you read the next step, you probably suggested some dowels. So I have some wooden dowels here, okay? And what I'm going to do is I'm going to place, let's make sure you can see, I'm going to place these wooden dowels onto the piece of wood, and I'm going to spread them out. By the way, maybe in social studies class at some point, maybe you talked about the pyramids and how the pyramids were built. Nobody knows for sure, but this is one hypothesis, that maybe the ancient Egyptians had these gigantic 20-ton blocks of stone. How in the world could they get them from one place to another? One theory suggests maybe they used big round logs to roll them. Who knows? But let's see what happens now that all I've done is added some wooden dowels. And by the way, think about the shape, the cross-section shape of these wooden dowels. What do they kind of remind you of? Maybe wheels. So let's see what happens to the force required to pull the same brick. The same brick has the same mass, has the same weight pulling on it from gravity, but do you remember how much force was required to pull it along the board? What was it? All right, let's see how that changes, if at all, by using these dowels. Oh my, oh my, oh my, wow. You know what? Just putting these dowels underneath the brick, I know you can't necessarily feel it through the screen, but you could probably see how much easier it is. It's requiring a little less than 1 Newton. A little less than 1 Newton. From 6 Newtons, and I don't know if you can see the length at which this spring scale is being pulled here. Maybe you can notice it. Watch this little apparatus here. From 6 newtons down to about 1 Newton. That is incredible. And if you thought that these round dowels were kind of like wheels, you're right. That's where the whole concept of wheels came from. And let's see what happens when I put this brick onto roller skates, which obviously are wheels here. All right, let's see what happens with our newtons. Oh, it's even less than the dowels. That's probably about 0.5 newtons. That's incredible. Now, think about this for a moment. You got a car. You know how easy it is to step on the accelerator. Well, hopefully you don't really, because you're not old enough to drive yet, but you've seen enough people drive that you step on the accelerator and boom, goes the vehicle. It's easy to ride. because the wheels go round and round, just like the wheels on a bus. But imagine if these wheels weren't on the vehicle. Now, can you imagine driving a car without wheels? It's not going to go very far. In fact, it's not going to go anywhere. Why? Well, it has to do with the friction. And wheels, as we're going to be learning in the near future, are a type of simple machine that can help make work easier. But for now, just think about this activity, the classroom activity that we just did together, and answer these questions in order to write your conclusion. And you can pause me now, discuss our findings, and then continue with the rest of your work for the day. So for now, all I'm going to say, bye-bye.